Magnetic field lines versus electric field lines. Both magnetic fields and electric fields possess field lines. Field lines are the imaginary lines that specify where there is an effective influence of force on the charges. The influence of force on electric and magnetic fields is quite different. Thus, this section lets us learn a comparison between magnetic field lines and electric field lines. Magnetic field lines. Electric field lines. Origin. Magnetic field lines generate from two poles of the magnets, starting from the North Pole and ending at the South Pole. Electric field lines induce the positive charges, and the negative charges are extinguished. Nature of charges. Magnetic field lines exist only if the test charges are under motion in the magnetic field. Electric field lines exist even if the test charges are stationary. It does not depend on the motion of the test charges. Existence of loop. The magnetic field line makes a closed loop around the two poles of the magnets. The electric field lines do not involve in the close loop as the test charges possess only a straight path. Nature. Magnetic field lines are parallel and never intersect with one another. Electric field lines are also parallel and are uniformly spaced and also do not intersect. Flow direction. The flow direction of the magnetic field lines does not depend on the potential difference. They always flow from the north to the south pole. The electric field lines always flow from regions with high potential to low potential. Comparative table of magnetic field lines versus electric field lines. Magnetic field lines versus magnetic lines of force. The magnetic field lines and the magnetic lines of force are fictitious entities that do not have any physical origin. In some contexts, it can be said that both magnetic field lines and magnetic lines of force are the same because they both specify the strength and the direction of the magnetic field around a magnet. In general, we can say that magnetic field lines depict the direction of magnetic force and its strength in the magnetic field. The strength of the magnetic lines remains constant throughout a given region, and it is proportional to the alignment of the lines. If the magnetic lines are arranged closely, the strength of the magnetic force will be more. The magnetic field line's density decreases if the distance between the poles of the magnet increases. If the magnetic lines of force were at the point in space, the magnet would be accelerated in the direction. Some points to be remembered. Both magnetic field and electric field are vector quantities, as both of them are associated with magnitude and direction. The magnitude of the magnetic field is proportional to the current carrying through the circular loop, while the number of field lines leaving the positive charge and entering the negative charge defines the proportionality between the electric field and the magnitude of the charge. The electric field can be a monopole but not the magnetic field. The electric field can be induced either by positive or negative charges, but the magnetic field exists only due to both north and south poles. The intensity of the magnetic field depends on the number of magnetic field lines produced around the magnet. The magnetic field is denoted by the letter B. It is given by the formula B equals /A, where is the magnetic force around the loop, and A is the area of the cross-section of the magnet. The electric field is denoted by the symbol E, expressed by the formula E equals F/C, where F is the electric force and C is the point charge. The tangent line at any point on the electric field describes the direction of the point charge, and also it represents the path of the positive test charge, which is free to move. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.